Hello everybody. In this video I want to get started by looking at one of the most common plots that we'll encounter, which are the column and bar plots. And we'll see there's just a tiny difference between the two, and Matplotlib gives us a really easy way to use almost an identical API for both of these guys. So the API between column chart and bar chart is going to look very similar, and we're going to get into that and then look at some real data here. So first things first, you should download the environment file and import it. So we've already shown how to do that, and then make sure that you have the correct environment. So the environment should be called DataViz. If not, click on the drop down and select the right one. So now that we have this guy set up, we'll have to do one more thing, and that is you'll have to download the DataViz source code. It's in a zip file, and you just double click on it or do a right click and extract all. I'm going to double click on this guy, and then we have the source code. So inside there's 3 folders, and you'll want to copy those folders into your whatever working directory you're going to be saving your files to. So in this case, I've created a folder called DataViz that I'm going to save all my code to in these folders here. So you'll want to copy over the folders in the DataViz source code over. And the reason for that is because all of the data that we're going to be working with, I've already pre-saved for us, so we don't have to fetch it. It's all in those folders. So after you do that, we'll be set. So I can go into Matplotlib, and you see I have all of these .pickle files, and without getting too much into it, Python comes with a library called pickle, and that allows us to load and save things efficiently as Python objects. So I'm going to show you we're going to get into all of these guys as we discuss the different plotting and charting types. So anyway, now that we have that, all the data in the folders, let's get started coding. So I want to go back into our Anaconda Navigator again. Make sure you have the right environment set up, and then let's launch Spider. I have an instance running up here, and I've just kind of gotten rid of some of the comments at the beginning. So I'm going to save this guy, and the first plot that we're going to be looking at is the column plot. So I'm going to save this as column .py. Okay, and so I've saved this column.py in the same folder as the pickle file. So we're going to be using Matplotlib for this video. So you want to save it in the Matplotlib folder. So if I open up Matplotlib, you'll see I have column.py. So all the Matplotlib videos, you want to save your Python files into this folder so we can access the data here. Okay, so let's get started with some imports. And so the first thing we'll need to import is, of course, Matplotlib. And all of the plotting functionality is in a submodule called pyplot. So I'll type import matplotlib.pyplot. But to simplify typing, because if we were to just do an import like this, then every time we wanted to plot something, we'd have to type this full name here, matplotlib.pyplot. Instead of typing all this out, we can create an alias, an import alias in Python. So to do that, I just say as plt, and everywhere I use plt, Python will know to replace it with matplotlib.pyplot. So this is just a convenient way for us to type much less, so we don't have to type this whole matplotlib.pyplot. We'll just type in plot. So we'll need this as an import, and our data is stored in a format called pickle, and it's just a Python library that lets us save and load Python objects efficiently. So we'll have to import pickle in order to load our data. So now that we have this, let's go ahead and load our data. And the general process for loading really anything from a file is that you open the file, you pull the data that you want out of it, and then you close the file. So we could do this in Python, but that's kind of a long way around. Instead, there's a Python syntax called with open, and essentially what that does is sets aside an indentation block, kind of like an if statement. It'll set off an indentation block, and everywhere inside of that block we can use our file. And after the end of the indentation block, it will automatically close the file for us. So we don't have to deal with any of the closing of the file and releasing the resource and all that stuff. We'll just put everything that we want in with OpenBlock. So we want to load our data. So let's load this guy. So the syntax is quite simple. We just say with open, and then inside here we want the file name. And our data is stored in a file called fruit sales.pickle. And this would just open it as a text file, but for efficiency I've saved the data in a binary format, so we have to tell Python to read from a binary format. So that's what this RB stands for. So here I'll say RB means read binary data. So we're now reading binary data, and then asf just links this. It creates a variable f that represents this file. Okay, and then I use a colon here to set up an indentation block. So inside of this block, now I can do anything with f, this file that I want, and then after I get out of this indentation block, it'll automatically close the file for me. Okay, so then I'll just load my data. So data equals pickle.load f. And so the only function on Pickle we'll need to know is load, and we just give it a file in this format, and then it'll load up all of our data. So let's see our data. And so now that I'm actually out of the indentation block, Python will automatically close this file for me. Let's see our data. So let me run this guy. As you can see, it's actually a list of tuples here. So each tuple has the name of a fruit, and then the quantity that's sold here. So that's what this is the data that we're going to be working with. And it's in this format, but what we can do to make our lives easier to work with is we can split this list of tuples out into two separate lists. So essentially we'll have one list that has all of the fruits, and we'll have another list that has all of the numerical values. So one of the lists will have, it'll be a list of apples, grapefruits, pears, oranges, and bananas, and the other list will have 50, 12, 43, 38, and 37. So we can do that using a Python function called zip. So here we are splitting a list of tuples into two lists. So we can use a syntax here, a Python function called zip. So I can say fruit, and num sold equals zip. And then there's a special operator that we have to use here. It's a special syntax. It's star or asterisk, and then data. And what this does is this is going to split our list of tuples into two separate lists. So we'll have a list of, so fruit will have all of our fruit here, and then num sold will have all of our numerical data. So this is just a special Python, built-in Python syntax that we can use to split a list of tuples into two separate lists. Okay, now we can print these guys out. Let's say, just to verify. So num sold, so I'm going to run this, and you'll see that the first list we have here is a list of all the fruits, and then the second is all of the numerical values, and these are technically tuples, but it doesn't matter for Matplotlib. Okay, so now that we have this, we can actually get to plotting our column chart here. And in order to do that, we need to tell Matplotlib where to position the bars. So we have to give it coordinates on the x-axis. We have to give it x-coordinates to tell Matplotlib where to put the bars. So I have a little picture here. So here are the bars of the columns, and we need to tell, so this is what we want the result to kind of look like, except for maybe we want these axes, or maybe we want it to be a different color or whatnot, or maybe we want this to be filled in. But regardless, we need to tell Matplotlib where to put these bars. And so we can put them, you see right now in this, they're positioned at 0, 1, 2, and 3, which is a good way to put these bars, although we have more data than that. So we need to create a list or some object, some Python list like structure where we say 0, 1, 2, 3, and then we can give that to matplotlib, and then matplotlib will know where to position them. So an easy way to do this is we can say something like bar chords equals, and we can use this range function that'll produce a list. It's technically a range object, but it can be treated as a list. We'll just say range length of fruit. So what this will do is this will create it will create a list, essentially a list that goes from 0, it starts at 0 and goes up to however many fruit we have. So we can, because we printed this out, we can figure this out. So it'll go 0, 1, 2, 3, and 4, because we have 5 fruit. So this will position our bars at 0, 1, 2, 3, and 4. So now that we have this data, we can tell matplotlib to plot this. So the function that we need to look for is plt.bar, and the first input to this guy is going to be these coordinates. So I have to tell matplotlib, hey, here are the coordinates. And then the second argument is how tall do I want the bars? And that's just the num_sold here. So this will set up. Now this is going to set up our bar plot, and then to show it, we have to call plot.show. So I'm going to call this guy, and now that I have this, I can actually run this, and we should be able to see our plot. So here is our plot. So you see we have these bars here, and they're positioned at 0, 1, 2, 3, and 4 because we told matplotlib to do that. Notice that it also goes the extra mile of centering them around the bar. So notice that this is centered around 0, 1, 2, 3, and 4. It's not like off to the side. So that's a neat thing that matplotlib can do for us. Now, how did I know that this was called plot? How did I know that this was a function bar and a function show? Well, we can go to the documentation. So you want to head over to matplotlib.org, and there's a link here called pyplot, and we click on that, and you can see we have all of the different plotting functions here. So we can scroll down and we can find show here, and there's all different kinds of plots you can use. There's spectrogram plots, histograms, we could do 3D plots, we could do contour plots, box plots, and the one that we're looking for is this bar plot. So I can click on this guy and it brings me to the documentation. And so it shows all of the parameters here, and then if I scroll down, there's some other extra parameters that you can mess around with. So there's like color, there's edge color, there's line width. So you can mess around with these parameters, give them to the bar function. You can mess around with them and see kind of maybe you want to change the color of the bars or something, and you can look over here for more information on what kind of inputs these expect. And then here's some examples as well as how to use this. So anyway, we have a column chart that's kind of functioning, but it doesn't really look nice. In fact, we need to pretty it up a little bit and do some other annotations. We want to give like a title to the plot. We need to label our axes, and then we need to change those pesky 0, 1, 2, 3, 4 to say the actual fruit. So so it's a good start, but we still have to improve on our plot.